Hello, Mr. Burrell here. We're in the unit on polynomials, and we've talked about different terms and definitions associated with polynomials. We've talked about adding and subtracting polynomials. The last section of this unit, we're going to be talking about multiplying polynomials. You might be thinking to yourself, what about dividing polynomials, Mr. Burrell? Well, that is a subject for another class, something to look forward to. So, to preface talking about multiplying polynomials, here are some of the things that I hope that you're able to achieve at the end of this lesson. I want you to be able to multiply polynomials together, a variety of them, and then understand that multiplying two polynomials together results in another polynomial. Okay, so if you were with a neighbor, I'd have you chat with your neighbor. But I want you to think to yourself, what is an exponent? What do we use exponents for in math? What do they mean? So if I have something like x squared or 3 to the 5th power, what does that mean? What does that exponent represent? Well, an exponent represents the number of times that I am multiplying something by itself. So x squared means I'm multiplying x by itself 2 times. So x times x. 3 to the 5th means I'm multiplying 3 by itself 5 times. So 3 times 3 times 3 times 3 times 3. If I had y to the 117th power, that would mean I'm multiplying y by itself 117 times. So that's what an exponent means. That's what we're going to be talking about here throughout this video. We're going to be utilizing this knowledge here in just a minute. You might have remembered if you were talking about adding and subtracting polynomials. Sometimes we're tempted adding and subtracting polynomials to do stuff with the exponents, but we didn't. We weren't supposed to do anything with the exponents. We were just combining like terms. That changes when we multiply polynomials together. So for example, here are a bunch of examples of monomials, and we're going to multiply them together. So 7 times 9, that's 63. That's easy money. We've done that before. X squared times x to the 7th, we'll come back to that one in just a moment. We'll talk about that one. 3x to the 5th times 4, that's 12. X to the 5th, 3 times 4 is 12, and x to the 5th kind of comes along for the ride. And then 6x cubed and 3x to the 5th multiplied by together we'll talk about in tandem with this second problem. So keep in mind that, again, an exponent just represents the number of times that I'm multiplying something by itself. So x squared is the same as x times x. X to the 7th is x times x times x times x times x times x, whatever, 7 times. So I end up multiplying x by itself 9 times. So the answer to x squared times x to the 7th would be x to the 9th. A lot of us are tempted to put x to the 14th, but we need to remember what an exponent is actually saying. An exponent is just talking about multiplication. So since I'm multiplying 9x's together, I write that as x to the 9th. Same thing applies here. 6 times 3 is 18, and then x times 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 x, 3x's and 5x's, that comes out to be 8x's. So I would write that multiplication as 18x to the 8th. So we're going to use that here in just a minute. But remember those rules when we're talking about multiplying bases with exponents together. So we're going to start by just multiplying a monomial by some longer polynomial. And we'll do a couple of these examples. So 8 times x cubed minus 4x in parentheses there. You might have heard the word distribute in relation to problems like this before. Distribution is something we talk about when we're talking about multiplication. So when I say I'm going to distribute this 8 into the parentheses, that means 8 needs to be multiplied by everything inside these parentheses. 8 needs to be multiplied by x cubed, and 8 needs to be multiplied by negative 4x. Well, 8 times x cubed, that's 8x cubed. 8 times negative 4x is negative 32x. So my simplified answer here would be 8x cubed minus 32x. And that would be it. That would be my final answer. No matter how long this polynomial out here is, if I have one thing in front of that parentheses, that one thing needs to be multiplied by everything inside these parentheses. Same here. This last one I will actually go ahead and do for us and kind of give as an example. So 4x squared times 3x cubed is 12x to the 5th, because 4 times 3 is 12. X squared times x cubed is 5 total x's being multiplied together, so that's 12x to the 5th. 4x squared times 6x squared, that's 24x to the 4th. 4x squared times negative 2x is negative 8x to the third. And 4x squared times 5 is 20x squared. And that right there would be my final answer. So that's multiplying a monomial by another polynomial. However long it is, you distribute that monomial into every single element of that polynomial. Okay, so now let's talk about multiplying binomials. Traditionally, when someone sees this problem, this is what I see a lot of the time. This is what I see people writing the answer as. X squared minus 12. Here's my x times x. Here's 3 times negative 4. But when I talk about distributing, when I'm talking about multiplying and I talk about the distributive property, that means that everything in this chunk, everything in this parentheses needs to be multiplied by everything in this parentheses. So in order to make sure that happens, I would need to multiply x by x, but also I need to multiply x by negative 4. Also, I'd need to multiply 3 by negative 4, but I'd also need to multiply 3 by x. Some of you may see this and recognize it as something called like the rainbow method or something like that. So after I do x squared and negative 12, now I also have x times negative 4, which is negative 4x. And I have 3 times x, which is a positive 3x. And combining all that stuff together, I get x squared minus 4x plus 3x minus 12. And notice in this problem, negative 4x and positive 3x, I can combine those together because they're the same. They're alike. So negative 4x plus 3x would be negative x. So x squared minus 1x minus 12 would be my final answer. And again, some of you may have learned it in this kind of sense with this kind of rainbow method. I'm going to introduce another method that I feel is more helpful, and if you like this method, use it. If you've learned the rainbow method and it works for you, use that. So here is the box method. So basically, I create a little grid, and I put one polynomial across the top of the grid and one polynomial across the side of the grid. So you'll notice this is a 2 by 2 grid because I have a binomial being multiplied by a binomial. So each of these boxes is going to represent me multiplying two elements of these binomials together. So for example, this box right here means I'm going to multiply this column and this row. So x times x, which is x squared. This box means I'm going to be multiplying this column and this row. So x times 3, which is 3x. This box right here means I'm multiplying this column and this row. X times negative 4 is negative 4x. And this box right here means I'm multiplying this column by this column, which is negative 12. Notice I got all the same answers as I got with the rainbow method. I personally feel that the box method is a nice way to graphically organize all the information you're trying to handle, kind of a good way to visualize it. And then in here you notice that these two boxes, this won't always be the case, but right now in these two boxes, I have my like terms, negative 4x and positive 3x, which add together to become negative x, which I got over here. I want to do one more example of multiplying binomials together. I have these other examples on here that you can continue to reference, but I want to go ahead and do this example right here. And I'm going to use the box method, and then I'll reference the rainbow method at the end if that's what you're using. But this is a binomial by a binomial, 2 terms by 2 terms, so I have this 2 by 2 blue grid. I'm going to multiply everything that corresponds with each of the boxes in this grid. So this box I'm going to multiply 7x cubed by x squared, which is 7x to the 5th. This box I'm going to multiply negative 3x by x squared, which is negative 3x cubed. This box I'm going to multiply 7x cubed by 9, which is 63x cubed. And in this box I'm going to multiply 9 and negative 3x, which is negative 27x. Now I'm going to write that out in the form of a polynomial. So I have 7x to the 5th plus 63x cubed minus 3x cubed minus 27x. Just as a reminder, I usually write my polynomials this way from the biggest exponent down to the smallest exponent because that's standard form, if you remember that. Most of the polynomials you work with will be in this form, and that's how most of the time we're going to write them. So now is there anything I can combine together? Any like terms in this polynomial I should be able to combine? Alas, there is. 63x cubed and negative 3x cubed. That makes 63 minus 3 is 60x cubed. So I have 7x to the fifth plus 60x cubed minus 27x. That's my answer. If you are using the rainbow method, notice 7x to the third times x squared, 7x to the third times 9, negative 3x times x squared, negative 3x times 9. You get all the same elements. 7x to the fifth plus 63x to the third minus 3x to the third minus 27x. The exact same thing as I got over here. Okay, so that's multiplying binomials. You can multiply any size of polynomial by any other size of polynomial that you want. We usually don't see much bigger than a binomial by a trinomial, but I'll give you an example of one that would be bigger than this. So the only thing I change when I start working with bigger polynomials, sorry, my camera is in front of that word, is I start making the grid bigger. So right here I have a binomial by a trinomial, a 2 by 3. So my grid right here is going to be 2 by 3. Whoops. 2 by 3. So I put one polynomial across the top, and I put one polynomial across the side. X plus 3, 4x squared plus 7x minus 1. And again, I just fill in all these boxes with these smaller multiplication problems. 4x squared times x, that's 4x cubed. 4x squared times 3, that's 12x squared. 7x times x, that's 7x squared. 7x times 3, that's 21x. Negative 1 times x, that's negative x. Negative 1 times 3, that's negative 3. So if I write all these out in the form of a polynomial, I have 4x cubed plus 12x squared plus 7x squared plus 21x minus x minus 3. And you'll notice, again, this doesn't always happen, but right in here, there are my x squareds. Those are the terms I'm going to be able to combine together. And here are some x's. I'm going to be able to combine those x's together as well. So 4x cubed plus 12x squared plus 7x squared is 19x squared, plus 21x minus 1x is 20x, and then minus 3. That right there would be my final answer. And I mean, you could multiply a 17 by 17 polynomial with a 17 by 17, or a 17-term polynomial with a 17-term polynomial. You just have a 17 by 17 grid. And you just do all these little multiplication problems and then combine all your terms together. We're never going to see one like that in this class, but know that that is something that could potentially happen. I want to just point out a problem like this. You'll see story problems like this on occasion. So you might remember we did a problem like this, Unit 1. The length of my whiteboard is represented by the expression x plus 4, and the width is represented by x. Write an expression that represents the area of my whiteboard. So if this is my whiteboard, this is x plus 4, and this is x, I'm trying to find the area of my whiteboard. The area is length times or multiplied by width. So that would be x multiplied by x plus 4. And now, I know how to simplify this. X multiplied by x plus 4, I'm going to distribute this x into both of these terms. I'm going to get x squared plus 4x. So that's an example of a real-world type problem that you would see that would represent multiplying polynomials together. So I hope that was helpful. That's all I have for you for this lesson, and I hope you enjoyed that as much as I did.